Nomenclature for transition. Transitions are metals that have more than one charge, so they have a variable charge. They are groups 1 through 10b in the old periodic table, or 3 to 12. They also include tin and lead, but we will exclude silver, which is +1, zinc, which is +2, and cadmium, which is +2. These three will not be considered part of the transition. These two will be considered part of the transition because they could be 2+ or 4+. Nickel is a transition element because it is found between groups 3 and 12. Symbol for nickel is Ni. The charge of nickel is given to you in the parentheses, Roman numeral 2. Phosphate is a polyatomic. Anything that ends in an 8 is a polyatomic. It is PO4. Charge is 3. The 2 and 3 cannot be reduced, so now we crisscross. The 2 from the nickel goes to the phosphate. The 3 from the phosphate goes to the nickel. So this becomes Ni3. We need a parentheses around phosphate because there's more than one 2. Chromium 6 oxide. Chromium symbol is Cr. It is a transition element because it is between 3 and 12. This is the Roman numeral 6. If the 1 is on the right side of the 5, then you add. Charge of 6, oxygen, O has a charge of 2. 6 and 2 can be reduced by dividing by 2. So if I divide by 2, the 6 becomes a 3, the 2 becomes 1. Now we need to crisscross down. The 3 from the chromium goes to the oxygen. The 1 from the oxygen goes to the chromium. So this is CrO3. Tungsten is also a transition metal. Symbol for tungsten is W. Charge of tungsten is Roman numeral 3. Carbonate, again, this is an 8, so it's a polyatomic. So it's CO3, charge of 2-. It cannot be reduced. 3 from the tungsten goes to the carbonate. The 2 from the carbonate goes to the tungsten. So this is W2, parentheses, because there's more than one polyatomic, CO3. We do not change the polyatomic, it stays as is. Charge of tungsten goes on the outside of the parenthesis. Osmium is also transition. It is symbol is OS. Charge is 4. If I have the Roman numeral 5 and the 1 is on the left side, you are subtracting 1. Chloride, it ends in IDE, so it's chlorine off the periodic table. It's Cl, charge is 1, cannot be reduced. So now we crisscross. The 4 comes down to the chlorine. The 1 goes down to osmium. So it's OsCl4. Iridium 5 oxalate is also a transition. Symbol for iridium is Ir. Charge is 5 given in the parentheses. Oxalate again ends in ATE. So this is a polyatomic. C2O4, charge of 2. Cannot be reduced. So the 5 goes to the oxalate. We're crisscrossing down. The 2 from the oxalate goes to the iridium. So it's Ir2, parentheses, C2O4, parentheses, 5. Vanadium 3 permanganate. Symbol for vanadium is V. Roman numeral gives us the charge of 3. Permanganate, again, 8 is a polyatomic, so that's going to be MnO4. Charge is 1. 3 and 1 cannot be reduced, so I crisscross. The 3 comes down here. The 1 comes down here. So it becomes V1, parentheses, because there is more than one polyatomic, MnO4, 3. Scandium 2 carbide. Scandium is Sc, which is also a transition. Charge is 2, given in the parentheses. Carbide is a nonmetal off the periodic table. C, charge of 4. This can be reduced, divisible by 2, so scandium becomes 1. Carbide becomes 2. I crisscross. So it becomes Sc2C. Zirconium 4 phosphite. So zirconium is Zr. Charge is given as 4. Sulfite. Ite is a polyatomic, so that's SO3. Charge is 2. This is reducible by 2, so sulfite becomes 1. Zirconium becomes 2. I crisscross down. So this becomes Zr1. There's more than one sulfite, so I need a parentheses. 2. Remember, when there is more than one polyatomic, you must put a parentheses. Tin 4 peroxide. Tin, even though it's not in the transition 3 to 12 groups, it is considered a transition found in the carbon family. Symbol for tin is Sn. Charge is 4. Peroxide, ide, even though it's an ide, this one is a polyatomic, so it's O2 with a charge of 2. Reducible by 2, so this becomes 1, tin becomes 2. Now I crisscross the charges down, so this becomes tin O2 because it's a polyatomic with the parentheses 2. Symbol to name. We find the name of the metal and write it as is. We use parentheses for the charge of the transition metal. To solve for the charge of the transition metal, multiply the number of nonmetals or polyatomic with the charge of the nonmetal or polyatomic, and then divide by the number of metals. Note, net charge of the atom must equal to 0. To do that, the number of metals times the charge of the metal must equal to the nonmetal numbers or polyatomic times its charge. All I did was rearrange the equation to solve for the charge of the metal. We find the name of the nonmetal, drop the ending, and add IDE. 5. Find the name of the polyatomic and write it as is. So the only difference from the fixed ionics is step 2 and 3. We must add a parentheses and we must find the charge of the transition metal because transition metals can have more than one charge. So we have CrPO4. Cr is chromium, so we find the name of the metal and write it as is. We need parentheses because chromium is in groups 3 to 12. PO4 is a polyatomic. It is phosphate. If we use the formula, we know that the charge of the phosphate ion is a 3. It's a minus 3. There is 1 PO4. So we multiply by 1. There's 1 chromium. So this is 1. So 3 times 1 divided by 1 is 3. Next one, MnO3. This is manganese. We need parentheses because this is a transition in groups 3 to 12. O is oxygen, becomes oxide because we drop the ending and add IDE. The charge of oxygen is 2 minus 2. There are 3 oxygens right here. There's 1 Mn, so 2 times 3 divided by 1. Manganese charge is 6. HF parentheses CO3 parentheses 2. This is hafnium. It's a transition metal between groups 3 and 12, so it needs parentheses. CO3 is a polyatomic carbonate. The charge of carbonate is a minus 2. There are 2 CO3. This is why we have a parentheses around it. So that's a 2. I have 1 HF, so this is a 1. So this becomes 2 times 2, which is 4, divided by 1, so this is 4. You could use the crisscross back method, but you must double check the nonmetal or the polyatomic. So when we have CrPO4, that tells us we have 1 Cr and we have 1 PO4. This 1 from the Cr came from the PO4, so we're going to crisscross back upwards. This 1 from the PO4 came from the Cr, so what we do is we go in reverse order. We're going to crisscross back up. That means the charge of chromium was 1 and the charge of phosphate was 1. If I check the charge of phosphate on the polyatomic, it is not 1, it is 3. So what I need to do is multiply both numbers by 3. So that tells you that the initial charge of chromium was 3, but it was reduced. Once you crisscross back up, you need to double check the charge of the polyatomic or the nonmetal. In this case, phosphate does not have a charge of 1. It has a charge of 3. So that means that chromium phosphate was reduced by 3. So I need to multiply the phosphate by 3. When I do that, I need to multiply chromium by 3. So the correct charge for chromium was 3, just like we solved. Let's look at the next one. We have MnO3. The 3 with the oxygen was from the manganese. The 1 from the manganese came from the oxygen. So I'm going to crisscross back up. So if I do that, the 3 goes up here to the manganese. The 1 goes up to the oxygen. So now we have to double check the polyatomic or the nonmetal. The charge of oxygen is not 1. The charge of oxygen is 2. So that means I need to multiply the 1 by 2. So that also means I need to multiply the 3 times 2. So the charge of manganese is actually 6, just like we have here. Let's look at the next one. HFCO3, 2. We're going to crisscross back upward. So hafnium has 1, so the 1 goes up here. The number outside the parentheses goes up. The 3 from the CO3 does not go up because this is carbonate. Without the 3, it is no longer carbonate. So the 2 goes up here. We check the charge of carbonate. It is not 1, it's actually 2, so we need to multiply each one by 2. So this is why the charge of hafnium is 4. NBP. Nb is a transition element found between groups 3 and 12. Is niobium. Since it's a transition, we need to put a parentheses. P is a nonmetal off the periodic table. Phosphorus, which becomes phosphide. IDE, drop the ending and add IDE. The charge of phosphorus is 3. There is 1 phosphorus here divided by 1 Nb, so the charge is 3. If I have NBP and I'm going to crisscross back, we know the subscripts are both 1. The 1 from here goes up here. The 1 from the Nb goes to the phosphorus. We look for the charge of the nonmetal or the polyatomic. Phosphorus has a charge of 3, so that means it was reduced, so we must multiply back what we reduced. So the charge of the transition metal is 3. Fe2 parentheses SO4 parentheses 3. Fe is iron. Since it's a transition metal, I need my parentheses. SO4 is a polyatomic. It's sulfate, ATE. The charge of sulfate is 2. There are 3 sulfates. Why? There's a parentheses telling you there are 3 sulfates. For a polyatomic, the parentheses tells you how many polyatomics you have. If it's a polyatomic and there is no parentheses, that means you only have 1 of them. So the charge of iron is going to be 3 because the 2 reduces out. So let's do it the other way. So there are 2 Fe's. This number came from the up here from the sulfate. There are 3 SO4s. The 3 came from the iron. I look up the charge of the polyatomic here, sulfate. The charge of the polyatomic is 2. So this is the correct charge. for iron, 3. PT parentheses C2H3O2 parentheses 4. PT is platinum. I need parentheses because it's a transition metal. This is a polyatomic acetate. The charge of acetate is 1. There are 4 acetate. Remember, outside the parentheses of a polyatomic tells you the number of polyatomics present. So in this case, there is 4. There is 1 platinum. So the charge is 4, which is IV. Let's do it the other way. So PT, C2H3O2, 4. The 4 at the acetate came from the platinum. Platinum has a subscript of 1. This 1 came from the acetate. If I look up the charge of the polyatomic, charge of acetate is 1, so that means the charge of platinum is 4. Whichever method you use, either the formula or crisscrossing back upward, make sure you do it correctly. If you choose to crisscross back upward, make sure you double check the charge of the polyatomic or the nonmetal. If it is not the same as its charge, you need to multiply the number until you get the actual charge of this polyatomic or nonmetal. And you need to do the same thing for the metal.